Hello everybody. Now we shall discuss about XY mode of operation. XY mode of operation. We know coming to YT mode of operation. In YT mode of operation, sine wave is given to Y input or test signal is given to Y input and internally generated sawtooth waveform is given to this X input. Then you can observe this waveform on the screen of this CRO. That is YT mode of operation. Okay. In XY mode of operation, uh, sine wave is given to this Y input. Instead of giving this sweep signal to X input, we are going to give external signal to this X input. Okay, this switch is thrown to this position. Then you are going to get XY mode of operation. Okay, that is you are going to give sine wave to Y input. This is Vy. Okay, and you are going to give another sine wave to X input instead of giving sweep signal. Then this mode of operation is called as XY mode of operation. Okay, this is what this is VH or VX. Okay, this is given to this sinusoidal signal is given to Y input. This sinusoidal signal is given to X input. Okay, let this is Vy is equal to Vy sine 2 pi f phi t plus phi. Let this is Vx is equal to Vx sine 2 pi fxt fxt. Okay, then Lissajous pattern will be displayed. Lissajous pattern will be displayed on the screen of the CRO. Okay, in XY mode of operation we are going to measure phase difference, phase displacement or phase difference, and frequency and frequency. Okay, measurement of phase difference. Phase difference using Lissajous figures. Okay, anyhow in X5 mode of operation you are going to get Lissajous figure or Lissajous pattern which will be observed on the screen of the CRO. Okay, assume two sinusoidal signals having same amplitudes, that is Vx is equal to Vy. Same frequencies, that is Fx is equal to Fy. And same sensitivities, that is kx is equal to ky. But there may be phase difference between two signals. Okay, okay, case 1. Let me apply 2 sine 314t. This is Vy. Okay, I'll do one thing. Here let me take kx is equal to ky is equal to 1 centimeters per volt. Okay, this is y input. This is a signal which is given to y input. Coming to x input signal, let me apply sine wave to x input 2 sine 314t. This sinusoidal waveform is given to y input and this sinusoidal waveform is given to x input, and there is no phase difference. There may be phase difference. Okay, but coming to case 1, without any phase difference, I am applying this signal to y input, I am applying this same signal to x input. Then what will be the pattern observed on the screen? Okay, now anyhow maximum voltage will be 2. Okay, t naught, t1, t2, t3 and t4. Here also t naught, t1, t2, t3, t4. Here also maximum voltage is 2 volts. Okay, negative maximum is minus 2 volts. Same here also minus 2 and this is 2 volts, right? Okay, now t t naught, t1, t2, t3, t4. Okay, now what is this Vx and Vy? Okay, x comma y. At t naught, what is Vx? 0 only. At t1, what is Vx? 2 volts. At t2, what is Vx? 0. At t3, what is Vx? Minus 2. At t4, what is Vx? 0. Okay, at t naught, what is Vy? 0. At t1, it is 2. At t2, it is 0. Minus 2. 0. Okay. X is equal to kx into Vx. Anyhow, kx is equal to ky is equal to 1 centimeter per volt. Then Vx will be equal to x. So 0, 2, 0, minus 2, 0. Y is equal to ky into Vy. Anyhow, ky is equal to 1. Okay. Then y will be equal to Vy. Okay. Y will be equal to Vy. 0, 2, 0, minus 2, 0. Okay. Now I am taking 1 division is equal to 1 volt. Okay. So x comma y 0 comma 0, 0 comma 0, 2 comma 2. Okay, 2 comma 2. Okay, 0 comma 0, again this minus 2 comma minus 2, 0 comma 0. Okay, so you're going to get diagonal line. diagonal straight line. For all instantaneous values of this as well as this, you're going to get diagonal line. Okay, so the pattern observed on the screen will be diagonal straight line in first and third quadrants and making an angle 45 degrees 45 degrees making an angle 45 degrees with respect to x-axis. Okay, you're going to get diagonal straight line making an angle 45 degrees with respect to x-axis. Okay, now case 2. If we have phase difference of 45 degrees, then what will be the pattern observed on the screen? Phi is equal, let me make phi is equal 45 degrees. Okay, then it starts from here, right? So this will be 90. Okay, T naught, T naught, T naught, T1, and this will be T2. This and this both will be equal. T1, T2, and this will be T3. I'll do one thing. Okay, now this will be T naught. This point will be T naught. At T naught, you're going to get this magnitude. Uh, this will be T1. This instant will be T2. This instant will be T3. Similarly, this will be T4, and this will be T5, and this will be T6, and this will be T7. Okay, okay. T naught, T1, T2, T3, T4, T5, and T6, T7, T8. Okay, you can also take this instant. This instant will be T8. This will be T7. Okay, okay, fine. You take kx is equal to ky is equal to 1 centimeters per volt. Okay, then at t naught, t vx vy x y and x comma y, you can also write x comma y. T naught, T1, T2, T3, T4, T5, T6, T7, T8. At T naught, this is Vy, this is Vx. Okay. At T naught, what is Vx? At T naught, Vx is 0. At T1, what is this? Anyhow, you take this Vy is equal to 2 sine 314 plus 45 degrees. Here this will be 2 sine 314. That's it. Okay. Now coming to this Vx. At T1, what is this value? At 45 degrees. This T1 is nothing but 45 degrees. At 45 degrees, what is the value of this voltage? That will be 2 sine 45 degrees omega t. Okay. 2 sine 45 degrees. Okay. That is 2 by root 2. Okay. This will be 2 by root 2. At 90 degrees, it is 1 into 2. Then you're going to get 2. 2 into 1 sine 90. Next, you're going to get T3. At T3, you're going to get 2 by root 2. At T4, it is 0. Okay. Okay. T5, it is minus 2 by root 2. At T6, it is minus 2. At T7, it is minus 2 by root 2. At T8, it is 0. Coming to this Vy, at T naught, it is 2 into sine 45 degrees. Sorry. Uh, this is omega t plus 45. Okay. Right. At T naught, it is 2 into sine 45 degrees. Okay. Then Vy is equal to 314 omega t plus 45 degrees. Vy is equal to 2 by root 2. At T1, it is 2 into sine 90. That is equal to 2. Okay. At T2, it is 2 by root 2. At T3, it is 0. At T4, it is minus 2 by root 2. At T5, it is minus 2. At T6, it is minus 2 by root 2. Minus 2 by root 2. At T7, it is 0. At T8, it is 2 by root 2. Okay. Anyhow, x is equal to kx into vx, then it will be equal to 0. This will be equal to this because x is equal to kx into vx. Okay, as kx is equal to 1, okay, then x will be equal to vx, then 0, 2 by root 2, 2, 2 by root 2, 0, minus 2 by root 2, minus 2, minus 2 by root 2, 0. Coming to y, y is equal to ky into vy. Ky is equal to 1 only, right? Then 2 by root 2, 2, this multiplied by this, then you get this 2 by root 2, 0, minus 2 by root 2, minus 2, minus 2 by root 2, 0, 2 by root 2, x comma y. What is x comma y here? X is 0 and y is 2 by root 2 is nothing but root 2 only. Okay. That is 1.414. This value will be 1.414, right? Okay, so let me take 1 division is equal to 1 volt. Then x is for this x comma y will be 0 comma 2 by root 2. Okay, 0 comma 2 by root 2. Okay, it is 1.414, right? Okay, then you can have point over here. Okay, 1.414. Okay, 0, 1, 2. Okay, next 1.414 comma 2. 1.414 comma 2. Okay, this will be the point. Next 2 comma 1.414, 2 comma 1.414. Then next 1.414 comma 0, 1.414 comma 0. Then next 0 comma minus 1.414, 0 comma minus 1.414, minus 1.414 comma minus 2, minus 2 comma minus 1.414, minus 2 comma minus 1.414, minus 1.414 comma 0, minus 1.414 comma 0, 0 comma 1.414, 0 comma 1.414. Okay, same point. You're going to get same point. Then this is rotating in clockwise direction. Okay, so you're going to get ellipse. Okay, you're going to get ellipse like this. Okay, in clockwise direction, in clockwise direction. Okay, this is the pattern which is observed on the screen, ellipse. Okay, in clockwise direction for the phase displacement of 45 degrees. Okay, so here you can write this is ellipse. Okay, you can have ellipse in clockwise direction, clockwise direction with major axis in first and third quadrants, okay. You're going to have major axis in first quadrant and third quadrant. Okay, first and third quadrant, first and third quadrant. Next, case 3. Let us take phase displacement of 90 degrees. Let phi is equal to 90 degrees. Anyhow, kx is equal to ky is equal to 1 centimeters per volt. Okay, so 90 degrees. This is Vy. Here Vy is equal to 2 sine 314 t plus 90 degrees. Okay. This is Vh or Vx. Okay, now T naught, you can take this point. T naught, T1, T2, T3, T4. Okay, here T naught, T1, T2, T3 and T4. Okay, T T naught, T1, T2, T3, T4. Okay, now what is Vx, what is Vy, and what is X, what is Y? At T naught, what is Vx? This is Vx. Okay, 2 sine 314 t. Okay, at T naught 0. At T1 it is anyhow maximum voltage will be 2. 2. At T2 0. At T3 it is minus 2. Okay, negative maximum will be minus 2. At T4 it is 0. What is Vy? At T naught sine 90. 2 sine 90 means you are going to get 2. At T1 0. At T2 minus 2. At T3 0. At T4 2. Anyhow x is equal to this multiplied by this, then you are going to get 2 0 2 0 minus 2 0. Similarly y will be equal to 2 0 minus 2 0 2. X comma y is 0 comma 2, 0 comma 2. Okay, then you're going to get point over here. X comma y will be 2 comma 0, 2 comma 0, 0 comma minus 2, 0 comma minus 2, minus 2 comma 0, minus 2 comma 0, again 0 comma 2, 0 comma 2. Okay, then you're going to get circle. Circle in clockwise direction. Circle in clockwise direction. Okay, so you're going to get circle in clockwise direction. Circle in clockwise direction. Case 4. phi is equal to 180 degrees. Okay, T naught, T1, T2, T3, T4, T naught, T1, T2, T3, T4, T4. Anyhow, kx is equal to ky, which is equal to 1 centimeters per volt. Now at T naught, this will be Vy is equal to 2 sine 314t plus 180 degrees. This will be 2 sine 314t. 314t. This is Vx. T naught, T1, T2, T3, T4. Next Vx, Vy, x comma y. T naught. At T naught it is at T naught it is 0. 0 to T2 it is 0. At T3 it is minus 2. At T4 it is 0. What about Vy? At T naught it is 0. At T1 it is minus 2. At T2 it is 0. At T3 it is 2. At plus 2. At T4 it is 0. Okay, so it will be 0. Anyhow, kx is equal to 1. 0 to 0 minus 2 0. This will be 0 minus 2 0 to 0. Okay, then 0 comma 0, 2 comma minus 2, 2 comma minus 2, 0 comma 0, minus 2 comma 2, minus 2 comma 2. Okay, then you're going to get diagonal straight line. Okay, diagonal straight line, making 135 degrees, with respect to x-axis. This will be 135 degrees. 135 degrees with respect to x-axis, and in second and fourth quadrants. Okay, this is a mirror image of this. Okay, so for different angles, phase differences, you're going to get different images. If it is 90 degrees or if it is 0 degrees, 0 degrees phase displacement, you're going to get diagonal straight line making 45 degrees with respect to x-axis. Okay, for 180 degrees, you're going to get diagonal straight line making an angle 135 degrees. Okay, this is mirror image of this. Okay, Now for 90 degrees, this will be 270 degrees. For 90 degrees, you are going to get circle in clockwise direction. Okay. For 45 degrees, okay, here the angle lies between 0 and 90 degrees in first quadrant, right? Then for 45 degrees, or if angle lies between 0 to 90 degrees, you're going to get ellipse like this, ellipse in clockwise direction. Okay, here angle lies between 90 and 180 degrees. Then here also you're going to get ellipse, mirror image of this in clockwise direction only, in clockwise direction. Here the angle lies between 180 degrees and 270 degrees, 270 degrees. Then you're going to get ellipse only, okay, like this, same as this, but in anti-clockwise direction. Okay, anti-clockwise direction, sorry, anti-clockwise direction. When phase difference is 270 degrees, again you're going to get circle but in anti-clockwise direction, anti-clockwise direction. If phi phase difference is lying between 270 degrees and 360 degrees, then you're going to get ellipse only, it will be same as this, but in anti-clockwise direction. Okay, here this angle will be phi will be, it is this phi will be sine inverse of y intercept by y max. Okay, here phase angle will be, that is phi 1, phi 2, phi 2 is equal to 180 degrees minus 180 degrees minus sine inverse of y intercept by y max. Let this is phi 3, phi 3 is equal to 270 degrees minus sine inverse of y intercept by y max. Here phi 4 is equal to 360 degrees minus sine inverse of y intercept by y max. You can find the phase angle. If you have image like this, you can find the phase angle between two sinusoidal signals. Okay, here you can take this. Okay, you can take this. Now what is phase angle here? Let us find. If you have eclipse like this, anyhow it is in clockwise direction, right? Okay, so I can find phase angle. Okay, ellipse in clockwise direction means it will be in first quadrant. Okay, so in first quadrant, what is the phase angle? Phase angle phi is equal to sine inverse of y intercept by y max. Okay, so here what is y intercept here? Here from here to here, this will be y intercept. I'll do one thing. Okay, now this is y axis and this will be x axis. Okay, and from here to here, this will be y intercept and this will be y max. Okay, maximum value. From here to here is maximum value y max, right? Okay, so this is y intercept. What is y intercept? Y intercept is equal to 2 by root 2. What is y max? Y max is equal to 2. Phi is equal to phi 1 is equal to sine inverse of y intercept by y max. Okay, then you're going to get sine inverse of 2 by root 2 by 2. Okay, then you're going to get sine inverse of 1 by root 2, that is nothing but 45 degrees. Okay, circle in clockwise direction means phi will be 90 degrees. Okay, you can also find, okay, here also sine inverse of 2 by 2. Okay, y max is 2 as well as y intercept is also 2. Okay, um, here also you can find. Okay, so if you have eclipse like this, okay, then this, sorry, from here to here, this will be, here to here, this will be y intercept, and this will be, from here to this will be y max. Okay, if it is in clockwise direction, then directly you can have like this. If you have ellipse like this, if you have ellipse on the screen like this, then you can use this formula. Phi 2 is equal to 180 degrees minus sine inverse of y intercept by y max. Okay, if we have ellipse like this on the screen, then this will be sine inverse of y intercept by y max. Okay, here also you can use this formula. Okay, anti-clockwise direction, all are in clockwise direction, all are in anti-clockwise direction. Okay, if this is in anti-clockwise direction, okay, then you have to use this formula. Okay, likewise you can measure phase angle. For different phase angles, you're going to get different patterns observed on the screen. Okay, in the next class we'll discuss about frequency measurement. Thank you.